Alright guys, I know it's Friday. Let's do some find the solution set for a quadratic trinomial where a is not equal to 1. We're going to be doing with positive negative combinations today. So let's take a look at problem number 1. Find the solution set. We've got 12x squared plus 7x minus 10 is equal to 0. So my first move, as usual, is let's see if I can factor something from 12, 7, and 10. Doesn't seem like it. So I have to label my A is 12, and my B is 7, and my C is negative 10. Okay, we're on a good track. So without further ado, I need to figure out what multiplies to AC and adds to B, because the A, the leading coefficient of this quadratic trinomial, is not equal to 1, so I gotta do the AC add to B method and split the middle term. So if I do 12 times negative 10, that AC becomes negative 120. So two numbers that multiply to negative 120, but add to B, which is positive 7. So whenever I see this, I get a little confused. So I like to calm myself down. If it multiplies to negative 120, I know that the combination needs to be some sort of positive negative. Okay. What does the positive negative mean if it adds to a positive? It means that the positive needs to be stronger than the negative. So make a list of positive times negative where the positive number is bigger than the negative. I'll let you pause the screen and figure this out on your own. I'm going to give away the answer in 5, 4, 3, 2, 1. So the combination that I found works is 8 and 15. But remember, 8 times 15 is 120. I want some sort of positive negative combination where the 15 is bigger. So it has to be negative 8 positive 15. Because negative 8 times positive 15 is negative 120. Negative 8 plus 15 is positive 7. So therefore, this combination wins. But what does this do? This allows 12x squared plus 7x minus 10 to split the middle term, specifically into negative 8x and positive 15x. Okay, so now we're in business. So now I've got 12x squared in the big fella, negative 10 in the small fella, and yes, they're rectangles, I call them fellas. But now these split bx's, it doesn't matter which one I pick. So if I put negative 8x here and positive 15x here, it doesn't really matter. Sorry about that. So now, what do? I'm going to cover the right column. I look at 12x squared and negative 8x. I'm going to factor out a positive, by the way. What can I factor out of 12x squared and negative 8x? What's the biggest number I can divide out of 12 and 8? Well, 4. And x squared and x share an x, so the GCF of 12x squared and negative 8x is 4x. Now, let's put the pieces together. 4x times what is 12x squared? 4 times what is 12? So 4x times 3x is 12x squared. 4x times what is negative 8x? Negative 2. 3x times what is positive 15x? That would be positive 5. Check your work. Is positive 5 times negative 2 equal to negative 10? Then you did it correctly. So now I'm going to look at these two. So specifically, I factored 3x minus 2 and 4x plus 5, and now it's equal to 0. We've done our job. We factored. We like a multiplication problem. I know I like a multiplication problem, especially when the outcome is equal to 0, because now I get to use the zero product principle. If I have multiplication and the output is 0, then I have to account for all the cases. Specifically, 3x minus 2 is equal to 0. or 4x plus 5 is equal to 0. Okay, so now let's solve for the left equation. 3x minus 2 is equal to 0. I'm going to add 2 on both sides. So 3x is equal to 2. And now I'm going to divide both sides by 3. So I can leave this as x is equal to 2/3. I would personally leave it like that because if you want the decimal equivalent, 2/3 is 0.66666666666. In other words, it is 0.6 repeating. And when we say it's repeating, put a little hat on that 6. And that's okay. You pick either one of these two, either 2/3 or 0.6 repeating. Personally, I like 2/3 because I like it when decimals end. You know, I get a little annoyed when they repeat or they go on and on and on and on and on. So I like the fraction there. So let's look at the other side. 4x plus 5 is equal to 0. I'm going to subtract 5 from both sides, leaving me with 4x is equal to negative 5. And now I'm going to divide both sides by 4. Oh, whoops. There we go. Cancel out, leaving me with a negative divided by a positive is a negative. Negative 5/4. You can leave it like that. I'm not mad. I like a fraction. But you'll notice that if you do negative 5 divided by 4, you're going to get negative 1.25. So one of the solutions could be either one of these two, negative 5/4, negative 1.25. They both mean the exact same, but I also want to see one of these two, either 2/3 or 0.6 repeating. So either way, left or right, I want to see both of those equivalent solutions. Okay, we're done with problem number 1. Let's go on to problem number 2. I'm going to put that paper away. 6x squared minus 5x minus 4 is equal to 0. I forgot to put that part. Find the solution set. First things first, can I factor anything from 6, 5, and 4? Can I divide something from all three of these and get whole numbers for all three? I don't think so. So I got to do that multiply to AC, add to B method. So specifically, A is 6, B is negative 5, C is negative 4. So I make my little table. In this case, A is 6, C is negative 4. So that would make my AC equal to negative 24. And my B is negative 5. Okay. If you want to do this on your own, pause the screen because I'm going to give the answer in 5, 4, 3, 2, 1. Okay. So if it multiplies to negative 24, that tells me that the combination needs to be some sort of positive negative. Okay, so a positive times a negative adds to negative 5. What does that mean? It means that the negative needs to be stronger than the positive. So without further ado, 3 times 8 is 24. But I notice that positive 3 times negative 8 will multiply to negative 24, and 3 plus negative 8 will add to negative 5. So if you got that combination, you are correct. So what's so special about positive 3 and negative 8? Well, it's because the A is equal to 1, we have to split this middle term into positive 3x, negative 8x. So now I've got 6x squared plus 3x minus 8x minus 4, where 6x squared goes in the top left, big fella, and the bottom right is the C, the little fella, negative 4, and the split bx's can go here. So my split bx's are positive 3x and negative 8x, so it doesn't really matter. I'm going to put positive 3x in the bottom left and negative 8x in the top right. Okay, now we're in business. I'm going to cover up the right column. I've got 6x squared and positive 3x. What can I factor? What can I divide out of 6x squared and positive 3x? What's the biggest number I can divide? Well, 6 and 3 are both divisible by 3, and x squared and x are both divisible by x. So the GCF of 6x squared and positive 3x is in fact 3x. I'm happy. I'm very happy. 3x times what is 6x squared? That would be 2x. Okay. 3x times what is positive 3x? Well, 3 times 1 would be 3, and we already have an x, so that would be 3x times 1 is 3x. 2x times what is negative 8x? Negative 4. Check your work. Is positive 1 times negative 4 equal to negative 4? Then you did it correctly. Okay, so now let's factor the dimensions out of the rectangle. We factored out 2x plus 1. 2x plus 1 times 3x minus 4. We did the factoring part. Now, 2x plus 1 times 3x minus 4 is equal to 0. It's a multiplication problem. I like a multiplication problem, especially when the output is equal to 0, because then I get to use the zero product principle. If I factor everything out and the output is 0, then either factor number 1 is equal to 0 or 3x minus 4 is equal to 0. Let's get down to business. So let's solve for the left part of the equation. 2x plus 1 is equal to 0. Well, I'm going to subtract 1 from both sides. And that gets me 2x is equal to negative 1. Okay, if 2x is equal to negative 1, I'm going to divide both sides by 2. And that gets me x is equal to negative 1/2. If you like a fraction, negative 1/2 is fine. If you're a decimal person like me, negative 1/2 is negative 0.5. Either one of these, they're the exact same. Now, let's look at the right side. 3x minus 4 is equal to 0. If I add 4 on both sides, now I'm left with 3x is equal to 4. So far, so good. Now I want to get x isolated. I'm going to divide both sides of the equation by 3. That cancels out. And now we've got x is equal to 4/3. That can't be reduced. It's an improper fraction, but it can't be reduced. I'm happy with that. But if you're a decimal person, fear not. 4 divided by 3 is 1 with 0.333333 because it's 1 and 1/3. So it'd be 1.3 repeating with a little hat on it. So either x is equal to negative 1/2 or positive 4/3. Either one, and I'm happy. X is equal to negative 0.5 or 1.3 repeating. Okay. All right, moving on to problem number 3. 20x squared minus 3x minus 2 is equal to 0. If you want to do this problem on your own, feel free to pause the video. Okay, 3, 2, 1. Okay, so we're finding the solution set. Well, spoiler alert, I can't factor anything out from 20, 3, and 2 and get whole numbers for all 3 of these. So I'm going to label out my parts. My A is 20, my B is negative 3, and my C is negative 2. Okay, so my AC, 20 times negative 2. 20 times negative 2 would be negative 40. And then B is negative 3. So now, what two numbers multiply to negative 40 and add to negative 3? So if it multiplies to a negative 40, that means that the combination needs to be some sort of positive negative combination. But Since it's positive negative, that add to negative 3 tells me that the negative needs to be stronger than the positive. So specifically, that combination needs to be positive 5, negative 8. Positive 5 times negative 8 is negative 40. 5 plus negative 8 is negative 3. And that's the winning team. You might have gone through the suspects of 1 and negative 40, 2 and negative 20, 4 and negative 10, but you would have won with 5 and negative 8. So because A is not equal to 1, we have no choice but to use the split the middle term method. So now we've got 20x squared minus 3x minus 2, where this middle term, negative 3x, gets split into positive 5x, okay, and negative 8x. Come on, pen. There we go. You've got some ink. There we go. So now we've got positive 5x and negative 8x as that middle term. So now let's put 20x squared in the top left, negative 2 in the bottom right, and I'm going to put positive 5x here and negative 8x here. Okay, I'm going to cover up that right column. What can I factor out of 20x squared and positive 5x? What is the biggest number I can divide out of 20 and 5? Well, 5. 20x squared and 5x both share a 5 that can be factored out, and x squared and x both have an x I can factor out, so that becomes 5x factored out. Now, 5x times what is 20x squared? 4x. 5x times what is positive 5x? Positive 1. 5x times 1 is 5x. 4x times what is negative 8x? That would be negative 2. 4x times negative 2 is negative 8x. Check your work. Is negative 2 times positive 1 equal to negative 2? Then you factored right. That bottom right, just FYI, if you factored correctly, then the bottom right is the product of these two dimensions. Okay, so now that we've factored these out, I look at this dimension, 4x plus 1 gets factored out, and 5x minus 2, I thought that was a plus 2 for a second, 5x minus 2 gets factored out over there. So now that we've factored this into 4x plus 1 times 5x minus 2, it's equal to 0. We've got a multiplication problem. I like a multiplication problem, especially when the output is equal to 0, because now I've got the zero product principle to help me find the solution set. All the values of x that make this statement true can be achieved with the zero product principle. So without further ado, according to the zero product principle, the left factor, 4x plus 1, can equal 0, or 5x minus 2 is equal to 0. So let's solve with the left side. 4x plus 1 is equal to 0. So I'm going to subtract 1 from both sides. That leaves me with 4x is equal to negative 1. And now I'm going to divide both sides of the equation by 4. I've got a negative divided by a positive, so that could be a negative. And I can leave this as 1/4, so negative 1/4. If you're a decimal person like me, negative 1/4 can be translated into negative 0.25. So either one of these works for one of the solutions. Again, one of the solutions. They mean the exact same thing. We have to move on to the right side now. 5x minus 2 is equal to 0, so I'm going to add 2 on both sides. So now I get 5x equals 2. So 5x is equal to 2. Divide both sides by 5. And this can be simplified as 2/5. you're a fraction person, that's awesome. You know what I am? I'm a decimal person. That's okay. So fractions are okay, but if you want to get really, really fancy, no, I'm just kidding. You can do whatever you want, as long as it's correct. 2/5 can be rewritten as 0.4. So, without further ado, x is either negative 1/4 or positive 2/5 if you're on team fraction. If you're on team decimal, x is equal to negative 0.25 or positive 0.4. Either way, you will get this whole equation equal to 0. Okay, last problem, and then we'll call it a day. 2x squared plus x minus 45 is equal to 0. If you want to do this problem on your own, pause the screen, and otherwise, I'm going to show you how to do it in 5, 4, 3, 2, 1. Okay, so remember that if you're ever unsure, there's no number in front of the x, there's an automatic 1. We can put this ghost 1 there, ghost 1. So now, I can't factor anything out of 2, 1, and negative 45. I guess if you want to factor out a 1, but that really wouldn't do anything. It just means it's the same coefficients. But a is equal to 2, b is equal to positive 1, and c is equal to negative 45. Okay, so I need to figure out the winning team that multiplies to AC and adds to b. In this case, the a is 2, the c is negative 45, so my AC would be negative 90. Multiplies to negative 90, adds to positive 1. Once again, I'm going to cover up this right column. If it multiplies to negative 90, that tells me that the combination needs to be some sort of positive negative. However, what does that add to positive 1 tell me about that positive negative combination? The positive needs to be stronger than the negative. So you make the table if you want to figure this out on your own. Otherwise, I'm getting the answer in 3, 2, 1. So you make that table, and eventually you realize that some sort of combination of 9 and 10 works. Specifically, negative 9 and positive 10, or if you wrote it the other way, positive 10, negative 9. The negative is in front of the 9, the positive is in front of the 10, because negative 9 times 10 is negative 90. Negative 9 plus 10 is positive 1. Yippee, we did it. So that's my winning team. The winning team for a quadratic, when a is not equal to 1, has the middle term get split. So specifically, 2x squared plus 1x minus 45 can split the middle term. We've got 2x squared minus 9x. Sorry about that. And then positive 10x. So now, 2x squared minus 9x plus 10x minus 45. I've got 2x squared in the big fella, negative 45 in the little fella, and the split bx's go in the diagonals. So I'm going to put negative 9x over here and positive 10x over here. I'm going to cover up the right column. Can I factor anything from 2x squared and negative 9x? What's the biggest factor I can divide and still get whole numbers? Well, 2 and 9 are not, they don't have any common factors besides 1, so I guess I could divide 1. But x squared and x both share an x, so I'm literally going to factor out 1x, or x. X times what is 2x squared? X times 2x is 2x squared. X times what is negative 9x? X times negative 9 is negative 9x. 2x times what is positive 10x? 2x times positive 5 is positive 10x. And how do we check our work? That diagonal should be the product of 5 and negative 9. Is positive 5 times negative 9 equal to negative 45? Then we did it correctly. So let's factor this out. In the left factor, one of the factors is 2x minus 9. The other factor is x plus 5. So now I've got a multiplication problem. I like a multiplication problem, especially when the product is equal to 0, because that means I can use the zero product principle. The zero product principle accounts for all values of x that make this statement true. So without further ado, we get the left factor and the right factor, and we set them both equal to 0. So we've got x plus 5 equals 0, or 2x minus 9 is equal to 0. Let's start with the left side. 2x minus 9 is equal to 0. I'm going to undo the layers of x by adding 9 to both sides. 2x is equal to positive 9. Good. I like that. I'm very, very happy. So now I'm going to divide both sides of the equation by 2, isolating x in the process. So now I get x is equal to positive 9 over 2. I'm very happy with that. It's a reduced fraction. Even though it's improper, it's still a reduced fraction. If you're on team fraction, it would be 9 over 2. If you're on team decimal, like me, 9 over 2 is 4.5. 4.5. These mean the exact same. These are equivalent values. Let's move on to the other side. X plus 5 is equal to 0, so I'm going to subtract 5 from both sides. Therefore, x is equal to negative 5. Hey, that was quick. So either x is equal to 4.5 or negative 5. X is equal to 9 over 2 or negative 5. And that is how we factor a quadratic trinomial. And I'm here to give you some good news. If you are awesome at factoring a quadratic trinomial, I guarantee you, Algebra 2, pre-calculus, calculus, you have a huge advantage. This is your foot in the door to getting a college degree, because this skill is vital to calculus. Have a great day.